Estimating a population mean. It's rare that we want to estimate the unknown value of a population mean, but we somehow know the value of a population standard deviation. So we now focus on the realistic situation in which the standard deviation is not known. Point estimate. As discussed in section 6.3, the sample mean is an unbiased estimator of the population mean. Also, for many populations, sample means tend to vary less than other measures of center. For these reasons, the sample mean is usually the best point estimate of the population mean. So, the sample mean, x bar, is the best point estimate of the population mean. Now, because even the best point estimate gives us no indication of how accurate it is, we use a confidence interval or interval estimate which consists of a range or interval of values instead of just a single value. So, confidence interval for estimating a population mean with the standard deviation not known. Objective: construct a confidence interval used to estimate a population mean. Here's the notation. We know that mu represents the population mean, x bar represents the sample mean, lowercase s is the sample standard deviation, lowercase n is the number of sample values, capital E is the margin of error. And what are the requirements? Well, number one, that the sample is a simple random sample. And two, either or both of these conditions are satisfied. The population is normally distributed, or n is greater than 30. Confidence interval. So here are the formats. You have x bar minus the margin of error, x bar plus the margin of error, and the population mean is in between those two values. Or we can say that the sample mean of x bar plus or minus the margin of error, or in interval notation we would say the sample mean minus the margin of error, comma, the sample mean plus the margin of error. So to find the margin of error, E is going to equal the critical t value times the sample standard deviation divided by the square root of n, and we would use df, which is an abbreviation of degrees of freedom, which is equal to n minus 1. Confidence level. The confidence interval is associated with a confidence level, such as 0.95 or 95%, and alpha is the complement of the confidence level. So for 0.95 or 95% confidence level, 1 minus 0.95 is 0.05. Therefore, alpha is equal to 0.05. Critical value. T subscript alpha divided by 2 is the critical t value separating an area of alpha divided by 2 in the right tail of the student t distribution. Degrees of freedom, abbreviated as df, is equal to n minus 1 is the number of degrees of freedom used when finding the critical value. Round-off rule. Number 1, original data. When using an original set of data values, round the confidence interval limits to one more decimal place than is used for the original set of data. Number 2, summary statistics. When using the summary statistics of n, the sample mean, and the sample standard deviation, you round the confidence interval limits to the same number of decimal places used for the sample mean.